This is lesson 8-1, video 4, and this next section on page 519 and following, I am going to try to uncomplicate as much as possible. I do think the book does a good job presenting it, but you may find that you need to pause the video, read what's in the book, rewind the video. It's a lot of words to take in and a lot of tying things together, so don't hesitate to do that to make sure that you're understanding. And I'm going to try to turn my camera so that we catch all of that little paragraph. Okay, so we are right here below Check It Out 2. You can use theorem 8-1-1, which is the theorem that we looked at on the previous page, talking about how when you draw an altitude from the right angle vertex of a right triangle to the hypotenuse, that you create three triangles that are all similar. The large original triangles and the triangle and the two new smaller triangles. So you can use that theorem to write proportions comparing the side lengths of the triangles formed by the altitude to the hypotenuse of a right triangle. All the relationships in red that you'll see below these drawings involve geometric means. So let's look at this for a minute. Let's look at how these relationships are being set up. So what we know is that when we have this altitude drawn from the right angle of a right triangle to its hypotenuse, we create two smaller triangles that are similar to one another, but also similar to the big original triangle. So now we're going to start understanding the relationship between all of those sides. So what you'll see here is that they are telling us that B is to A. This is like a multi-step proportion. B is to A. Let's find small b. Here's small b, and here's small a. So what we're looking at is the large triangle, and we're looking at the longer leg over the shorter leg. That is the same as Y to H relationship. So long leg to small leg of big triangle has the same relationship as long leg to short leg of the medium-sized triangle. That's triangle DCA right here. So B is to A in the same way that Y is to H. Both are comparing long legs to short legs. In the same way that H is to X. So now let's look at the itty-bitty triangle. Long leg to short leg. So it's telling us all those relationships are the same. Long leg to short leg of the biggest triangle is the same proportion as long leg to short leg of the medium-sized triangle is the same proportion as long leg to short leg of the small triangle. All right, we'll look at other proportions in there. The next one is C to A. So let's find C, little c. Little c is the big, long hypotenuse of the largest triangle. So it's hypotenuse to shortest leg. So that proportion is the same as B to H. B is the hypotenuse of the medium-sized triangle right here. So B to H, which is the shortest leg. And again, we're going to do hypotenuse to shortest leg, hypotenuse of little bitty triangle to shortest leg of little bitty triangle. So they're telling us that those are all the same proportions. And as you'll see, I wrote below them what those relationships are. This one is longer side to shorter side. This one is hypotenuse to shorter side. And the last one is hypotenuse to longer side. Let's look at that. C is to B, as B is to Y, as A is to H. So let's look at that. C is to B, big long hypotenuse is to longer side of the big triangle, as B is to Y. Let's find little b. That's the hypotenuse of the medium-sized triangle is to longer side of the medium-sized triangle in the same way that hypotenuse of the itty-bitty triangle is to the longer leg of the itty-bitty triangle. So I hope y'all can see all of that. The reason that we have letters in red here is that they pointed out to you that all the relationships in red involve a geometric means, so that H's are the geometric means of Y and X. The A's right here are the geometric means of C and X, and the B's are the geometric means of C and Y. All right, moving on to the bottom, let's look at these corollaries. This is going to give us a mathematical relationship of a couple of those relationships that we were just looking at. So this is the first one. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. Let me let you look at the diagram while I read that again to help understand it. The length of the altitude, which is h, is the geometric mean of the lengths of the two segments of the hypotenuse. So there's one segment and there's the other one. So this is going to be the geometric mean of x and y. Therefore, you might imagine that we could write it as x over h is equal to h over y. And now you can see that it is actually the geometric mean of x and y. That mathematical relationship is going to work out like this. H squared equals x, y. Let's come to the example they gave us, and you'll see that that's exactly what they tell us the relationship should be. H squared, or that altitude squared, is equal to the two segments of the hypotenuse multiplied together. Same relationship that we looked at the top of the page with the geometric mean. We could also rewrite it by taking the square root of both sides and say h is equal to the square root of xy. All right, you're going to need to be applying that a lot in your homework, so you're going to need to come back to this over and over. Let's look at the second one. The length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. All right, I'm going to let you look at the diagram again while we read through that again to make sense of it. The length of the leg of a triangle, so let's say we're looking at the big triangle and let's look at leg A. The length of the leg of a right triangle is the geometric mean, so let's set that up. We're going to put it in the geometric mean spot. The length of the leg of a right triangle is the geometric mean of the lengths of the hypotenuse. So one of them has to be the whole hypotenuse, which in this case would be C, and the segment of the hypotenuse that's adjacent to that leg. Now remember, adjacent means next to. So the segment of the hypotenuse that's adjacent to A is X. So it says this leg of the right triangle is the geometric mean of its adjacent segment of the hypotenuse and the whole hypotenuse. So we have x is to a as a is to c. This would work out to be, algebraically, to be a squared equals x c. And let's look over here. That's exactly what they told us would happen. A squared is going to equal xc. If we were to do it with the other leg of the triangle, it would be b squared, as you can see right there, equals y. That's the adjacent segment, this time of the hypotenuse, times the whole hypotenuse. So this time it's b squared equals yc. Now remember, for solving problems, we simply could take the square root of both sides of this top one and rewrite it as a equals the square root of xc, or the bottom one, take the square root of both sides, and b equals the square root of yc. All right, we are flipping to page 520. I am going to start a new video and we will look at the example that goes with this.